For this video, let's talk about a unit vector. We know that a vector, or specifically a direction vector of a line, tells us about its tilt or possibly related to the slope when we talk about some high school geometry or high school topics related to this. Now, when we talk about this perspective here, definitely we can always get the vector of a line, or again the direction vector of a line passing through two different points. Specifically, if we're talking about these 2 points, we can actually get its vector, but that vector is not necessarily a unit vector. Hence, we'll be implementing a set of process in order for us to transform that direction vector into a unit vector. And this unit vector will be very important to be used in some important concepts as we push further in the topics here, analytical approaches to modern geometry. So let's start with the idea of the vector passing to the points x to y. We know that the vector for that can be represented by a difference of y and x. So this means that this is actually equivalent to the components -3, 2, the minus 2, and 1. This would be equal to -3 minus 2, and then 2 minus 1. This is actually -5, and this is actually +1. What we usually do to represent vectors is the use of brackets so that we could actually differentiate this with the use of points. But this time, let us reintroduce the use of parentheses, but I caution you to not to be confused with this, as this is a vector, not a point, okay? Because later on, in solving for the unit vector, we'll be using this. The unit vector, as mentioned, is a vector of magnitude or length 1. We don't know the length of this given vector here, but to represent it with unit vector or the vector of magnitude and length 1, we'll be using this notation. By the way, some references would like to use this, but for the purpose of parallelism and similarity to what we usually do here for same topics in this playlist, let's use here v sub u as the unit vector. Again, just for the purpose of this discussion, let's talk about v sub u. This is represented or can be solved by your vector to be divided by its length. Okay, this is the length of the vector. So when we talk about the length, the vector itself to be divided by its length, we can always get a unit vector or a vector of magnitude 1. Okay, so what is actually length of a vector? The length of a vector, as we know, is actually the square root of the first, or the square of the first components and the second components. Okay, so we had that in one of the videos in this topic or this series on analytical approaches to modern geometry. You might want to review on that. So this case, we have here our v sub 1 being -5, our v sub 2 is +1. So the length of this vector is the square root of the square of -5 and the square of 1. So we will have here you have your 25 plus 1, which will have square root of 26. This is the length of vector v, which will be substituted that here. So we have the unit vector of vector v is actually the vector v in parenthesis notation -5 and 1 to be divided by the square root of 26. This is our unit vector. Now, don't worry about a radical expression on the denominator. Just at this point, do not rationalize it yet, because we'll be subjecting that to another process, and it's easier for us to do this. Of course, other references would like to have -5 over square root of 26. So because the denominator of square root of 26 is actually 1 over square root of 26, and by scalar multiplication, you can have this in 1 over square root of 26. Either way, they mean the same thing. This is now the unit vector, or this is the vector of magnitude or length 1 pertaining to the direction vector of a line passing through the points x and y. Now, how about y and z? So let's determine the unit vector of a line passing the points y to z. So again, the vector of that is z minus 1, y rather. Our z is 4, -2. So you have 4, -2. Our y is -3 and 2, -3, 2. So you'll have here 4 minus -3, -2 minus 2. So we will have here 4 plus 3 is 7, and you'll have here -4. Again, we used brackets before to represent vector or direction vector. This time, let's reintroduce the parenthesis, not a point but a vector. So let's talk about its unit vector as the ratio of the vector itself and its length. Now the length, as mentioned, is equal to the square root of the sum of the squares of the components. This is our v sub 1, this is our v sub 2. That's v sub 1 squared, v sub 2 squared. You will have here, v sub 1 is 7 squared plus the square of negative 4. This is equal to 49 plus 16. So that is square root of 65. This is the length of vector v for the line passing the points y to z. And going to that, the unit vector here is represented by the vector itself using parentheses 7 and negative 4 to be divided by square root of 65. Or again, you will have here 7 over square root of 65 and negative 4 over square root of 65. This is the unit vector of the line passing the points y to z. This is how we solve the unit vector, and this again will be used in one of our topics, specifically the foot of perpendicular, and so on and so forth. Okay, so as for the unit vector for the line passing through points x and z, I'll be leaving that to you as your exercise. Just simply duplicate the process here, and of course, internalize all the necessary processes. Thank you very much for watching.